3 blowers, 1 Ford block, a tube, no belt, not running anything. You want to see what's going on here, you better watch this video. Hey everybody, in this episode we're going to show you a true street that's an NMCA class where they got to drive this engine and make 3 back-to-back passes. So they make a drive, put it in the staging lane, make 3 back-to-back passes without touching the car. This thing makes some serious horsepower with twin TorqStorms, and the TorqStorm guys are here. We're going to actually test some other stuff, including a single blower instead of the twin, and I'll go over the whole package here with you in a minute. Alright, so this engine is for TorqStorm themselves. So those guys have 2 or 3, I think they have 3 race cars right now that they're racing and doing all their development work and testing work on for the blowers. Now, first off, let's cover the engine. This is our Stage 2 500, basically our Stage 2 540 cubic inch engine. Now this one happens to be a little bit bigger than that because this is the one that actually converted and used some parts that they already had, so this is 565. But the same thing as our Stage 2 engine that you'll find right on our website, with billet intake upgrade, and let's see, this is a steel rod motor, yeah, because it's on gasoline. So let me tell you exactly what they got to do. And then we'll go back to the engine. So like I mentioned in the preview here, so what they have to do is when they go to make their passes for the day, they can do all their testing and do anything they want there before the race. But during the race, they have to go make a 25-mile drive, put the car in the staging lane. You cannot touch the car. You can't do anything except set tire pressure. That's it. You can't add fuel, subtract fuel, change fuel, pop the hood. You cannot do anything. You have to race it, and you have to race it round robin. You can't come back and cool down. You can't do any of that crud. You literally have to go make a pass, come right back up in the staging lane, and they make you make another pass, then come back up in the staging lane and make you make another pass. So that's why this engine combination kind of fits our niche of what we do, which is duration, drag and drive kind of stuff. So this is a little bit different kind of drag and drive, but basically is a drag and drive. The not cooling down in between rounds is kind of a big deal, actually. Now, this is based off our normal 540 Stage 2 package. So compression ratio is everything all lends itself to being on gasoline. So we can make these kind of drives and everything, because you're not going to be doing this on methanol. You can't make 25-mile drive on methanol, and I don't even think they allow methanol in the class anyways. So this thing can run on pump gas because it is intercooled. Now he has a big air-to-air intercooler in it, and so that's why we're simulating it with my big air-to-air intercooler. Compression-wise, go back to that. These things, we typically set them up at about 10 to 1, right in that range. This is a steel rod motor because it's gasoline. Methanol motors, we almost always use a aluminum rod in those. Has our billet manifold upgrade. This is Holley EFI. This has a Dart 380 cylinder head on it. We'll typically use those, or we'll use the Brodix 383 headhunter heads is our typical deal. Just so belt drive, standard camshaft, 842 lifter. This is just a really good, solid general piece like what all our Stage 2 stuff is. Like I said, you can go to the website and you can see what the Stage 2 package includes. Now, what we're going to do is we'll make our baseline pull, and this does make really good horsepower, especially for how much boost it makes. Now, before everybody gets all gung-ho and says, but it's got two blowers on it, why doesn't it make 5,000 horsepower? Listen, that's just not the point. Part of the packaging and everything that the TorqStorm guys do is, this is a legit serpentine drive system. The whole point of what they're trying to do is, you can put AC on this, alternator, power steering pump, everything can all fit, and they have bracketry for all of this stuff, which makes it nice. It's symmetrical. It's just kind of a nice, cool package. It doesn't need to make, and they're not trying to make the maximum horsepower with their systems. But this makes some really good horsepower with the system. We are going to show you that they're developing and working on a bigger single blower for the extreme street class, a 91 millimeter supercharger, to compete in that class. And we're going to test it on this engine, which would be too big for that blower, technically. If you ever wanted to see anything about that, go to my playlist and you'll see some sections about blower speed and how blowers affect, how the engine, you can have too much engine for the blower. Let's just put it that way. So there's a lot of stuff you can do there. So we're going to test some other stuff, but first, let's go ahead and make a pull here. We've already done all the tuning, everything's all good. We're going to make a pull on this thing, show you where it's at right with this pulley combination, this boost, what this thing makes, which is, like I said, really good horsepower, especially for something that is drag and drive and no cool down, no anything, no changes, tire pressure only. So let's go make a pull on this thing. Alrighty, so that's like I said, it's really nice power right there. 1,898 horsepower. Did mention it's when I said gas, C16. So it will run on pump gas at a little lower boost level than what this is, and we'll go look at the boost right now. And right there you can see that is at 18.5 pounds of boost. This one I think is, this Dyno is gauge is a little bit less. I think it actually says like 19 on the Holly. So that is our really good spot. Torque wise, 1,605 foot-pounds of torque. Alright, so now we just made that pull, and I wanted to show you the spark plugs, because we always have questions about spark plugs. So you can come here, look at my little spark plug holder thingy, and it's kind of a clustered mess over here right now. But one of the things that we did here is, for Scott's car, we had, he used to be running this with a blow-through carburetor. And blow-through carburetors are fine, no problem. But this is obviously getting at that magic horsepower area where the carburetor it's just physically impossible. It is beyond physics to make. Physics might be the wrong terminology, but it is not even rational to think that this carburetor can distribute fuel equally. One carburetor can distribute fuel equally to all 8 cylinders. So hence and that's the same thing with the snipers or any throttle body type injection system. Individual port injection, we can do a much better job of controlling individual cylinder fuel. A carburetor, you cannot control individual cylinder fuel. There's always a sacrifice that one cylinder is going to be leaner than the other, one cylinder is going to be richer than the other. It just is what it is. So you're always balancing, trying to make the happiest compromise. Problem is, the higher the horsepower you go, you'll tend to have an issue. Somewhere down the road, it's going to pick on a cylinder and hurt apart. It just does. So that's why I don't like to have this. This was because Scott did run this engine in that 1,850 to 1,900 horsepower level. Thankfully not very often, because that was actually faster than what the car could go legally. So in that really high horsepower level, it will hurt some parts. So Scott wanted to change this thing over to the billet intake manifold, which I wanted to change them over to it because it's just better, and it is just drop dead sexy. So sexy. It's the best looking manifold in the market. Yeah, anyways. You can see the spark plugs here, look real good. Everything's very even too, which is what we get with the EFI port injection versus a carburetor. Carburetors are great. Carburetors have their place. The higher the horsepower, just is very hard to make them work, and you will always have some kind of problem. So everything looks great here. That's all cool. So I think now we're going to, we just wanted to re-baseline it before it changed over to everything on the single. just testing it. And like I said, they're just testing it on an engine that's too big for that single small blower, because that single small blower is built for 400-ish cubic inch engines in extreme street. We're going to show you also the TorqStorm guys here, back there. Let's do a selfie here. Well, you can't do it. There you go. There you go. All right. Oh, I like it. They're all lined up too, like ding, ding, ding. Okay. Anyways, they're going to show you too a very interesting deal you need to watch on how much horsepower it actually takes to run a blower and how we actually determine that. I'll show you that here in just a little bit too. So first thing we're going to do, this is our baseline. It's all tuned up. This is where it's going to run in the car normally. So right where it's going to run in the car. Now that Scott has actually put a 750 cage in it so he can go faster than 850s like he was going. So he'll be able to go faster in that class. We'll be able to utilize all the horsepower that's there. So we're now going to put on a single one that isn't for this engine, isn't for this class, but is for the extreme street class. So they're going to put that all on there. We're going to do some testing and then do some testing on how much horsepower it takes to run that blower, which you'll find interesting. Okay, so it looks a little odd, so get over the looking odd thing, because this engine, so this is Chris. Chris is the other half of TorqStorm. This is Scott's motor, who is the other half of TorqStorm. So it's going to end up having the other blower put back on. So he didn't bother taking that one off. So that one's not getting driven by anything. But this is the new blower that you want to test. Tell us a little bit about it.
It's the TS91R. It's our new bigger blower. Seeing some good stuff on our test stand. We need to test it on a motor and do some comparisons, see where we're at.
Okay, cool. You'll see here too, they did a billet volute for it. So obviously they're developing with the billet volute and then going to end up casting pieces for it, obviously.
Yeah. We're going to still do the billet center section.
Oh, so it has a bolt-in billet center section,
Yep.
A landing area?
Yeah, we're going to keep doing that so we can, because there's advantages to that over the cast.
Sure.
The different things you can do to the landing area.
Sure. Okay, that's cool. And then you told me that so this is, you want to get on the back side, so this is a 6-blade setup. So you told me something interesting there, that what you found. So they're measuring at their facility, they're measuring airflow, temperature, and pressure. And that the 6-blade is actually better than, in this blower, the 6-blade is better than the
7 and 8.
So you had a 7 and 8 blade, and those made more temperature.
Right.
At same PSI boost, yep. Same drive ratio, everything.
Yep.
So that would mean less horsepower. That's just basic math. It does. So the other thing we're going to do here, I'll show you in just a minute, is then we are going to test how much horsepower it takes to drive this blower. And I'll show you exactly how we're going to do that, because it is so stupid easy, but really interesting the way it all works. You just don't even think about it. But you'd be surprised, and we have other blowers over here that we're not going to mention or talk about, but we're going to actually test those too, because it's just kind of interesting to see direct comparison here. So anyways, let's go out and make a run on this. So this will be exact same tune-up as with the twins, just with the single. All we want to do is just see what it does.
Right.
And so since we're also leaning on it, or spinning it up pretty good, how fast you spinning this?
It's only 60,000 on the impeller speed.
Okay.
So we spun it harder than that on our test stand. But
yeah.
If this motor went more RPMs, we could run it harder, but it's like done at 67. So.
Oh, what, this engine's done at 67?
Yeah.
No, not really. I mean, it's still running up there.
Oh. Well, if you can run it harder,
it's Scott's engine. We could run it up like $9 grand.
That's what I say.
Yeah, so but don't matter to you.
It's not my motor.
Well, and I'll say, Chris.
I want to make sure he sees that in the video.
Chris told me to run your motor up to $9 grand. Sorry, it broke. So let's go out there and run this thing real quick. Yeah, nothing broke there. That's good. All right, so this is what are you calling this blower again?
This is the DS91R. This is 91.
DS91R. DS91R.
T as in TorqStorm.
T.
No.
RT?
TS.
TS. All right. Okay, so single blower mode, 1574. I mean, I ran it up to 76. It's just where it naturally lays over at. So at 6,900 RPM, 1259. Go look at boost, and we'll look at the data logger on the. Yeah, look at the data logger on the Holly here. So looking at our boost here, so it either is slipping the belt, or it's just naturally it's running out of air either, possibly.
I'm thinking not.
Okay,
But,
thinking it's slipping
I mean,
the belt. What do you think it should make for boost?
Well, I don't know. We're not spinning it very hard. That's the thing. What did you say you went up to?
75.
75.
Yeah.
Well, that's getting pretty close to where we need to go.
You keep it running.
So maybe it is slipping the belt.
Let's go in there and see if it's slipping the belt here. So we'll check it out.
Figure out what that actually should have been.
Let's turn this water pump off. It sounds right. It sounds good.
75.
I don't see any belt residue.
This is 76,000 on the impeller,
Yeah.
which is pretty close to what we ran that Procharger at then too. Actually, impeller speed. What's up that had belt slip, so we don't know if that was.
Okay. I mean, I think the power's good for the pounds of boost. I mean,
Yeah.
12 psi boost and 13 pounds of boost, and it's making 15, almost 1,600 horsepower, so the power's good. What brand X blower make?
It made, it was 1580, 1589.
Okay, so really close to the same.
Yeah.
Hmm.
But it's a 94 to a 91.
Oh, okay. All right. Well, that's cool.
Yeah.
We'll look at the Holly data here and see what it's making for temperature. Did you take temperature off the other one too?
Yeah, it was 263, I think.
Okay.
Our 3-inch tube isn't going to be a problem, is it? It's close to 3.5 all the way.
Well, it definitely would be better. There's no doubt about it.
Yeah.
So this blower is obviously designed for a 3.5 inch.
Yep.
You want to put a 3.5 inch on it? I got enough stuff to do it.
Yeah.
Yeah.
Do you think it'd make that much of a difference? I mean, the inside of the tube is 3-inch.
Hmm?
The inside of the tube is, of the volute is 3-inch.
Basic plumbing principles apply. Bigger's always better. Always flows more. So probably worth trying, but it wouldn't change anything outside of would change temperature right there. It doesn't care about that. And we are probably taking some hot air here too. I mean, theoretically, we really should probably have a logo out or something. But it's still a pretty decent comparison to what it would be. I would expect it to be at least a little bit hotter, sucking off the header. Yeah, you want to just put the 3.5 on there and just see if it makes a difference?
It can't hurt.
Yeah.
If you guys got time. I know you guys are kind of hurting for time.
Well, I wasn't actually going to do it myself. I was going to make you guys do it.
No, that's fine. No, we'll do it.
So, yeah, no, I gathered up some tubing upstairs, and I think we have enough stuff to make it all happen here. Let's see if we can make that, because that's a 3.5 inch inlet on the on the intercooler, anyways. Yeah, and I wouldn't be surprised if it's, I don't know, it's a. So the deal is with with big cubic inch engines, I mean, it should run this thing out of air. Really,
Okay.
it should, and I think it probably is.
Well, you would know more about that than me.
So, yeah, I mean, you can't put any of those smaller blowers on that kind of big engine. I mean, they'll make good horsepower and then lay over, and that's exactly what it's doing. And then it just flat lines on boost.
Right.
It would probably make, in fact, it would make more horsepower on a smaller cubic inch motor at a higher RPM.
So like that LS we're gonna run it on.
Yeah, I wouldn't. I'd probably. Yeah, see, this blower is actually going to go on Chris's LS.
Right.
So we're gonna, if I can get time before we go to sick week, we're gonna try testing that too. It probably will make more horsepower on that. At minimum, I guarantee it'll make the same, but it should make more horsepower on that engine than what it makes here. Because this engine's just too big.
Well,
So-
that's what we wanted to see.
That's what we want to see what it would
Right.
do. Okay. Well, let's look at some Holly data, and we'll look at your air temp, see what that is, see if that correlates to what you're testing with,
Yeah.
and then what more do you want to do on this besides do the
Just-
horsepower test?
Yeah, just the horsepower. Unless we change that tubing, see if that does something.
Oh no, yeah. I'm sorry. We'll change tubing
Yeah.
first. So we'll go. I'll go gather up some tubing, and you guys can work on that. We'll look at that real quick, and then we'll come back. So a little interesting, I didn't have 3.5 inch pipe, so I had them put on 4-inch pipe, which is no problem. So it'll be interesting to see if it does pick up anything, or if it does anything from the bigger pipe. It does in the bigger engines, the bigger blowers, it always does. Like 4-inch to 5-inch pipe is a pretty big deal, especially if it's going through intercoolers and stuff. Makes a pretty big difference. But here, we'll see if it does anything. And we're gonna look at air temperature real quick. Air temperature. Gets up to 225. Sweet.
267 on the other one.
Oh, okay. That's cool. Really? That's good. That's a big difference. Yeah. Huh.
Right, 267?
267.
Yeah. Huh. Okay. So 225 degrees of air temp on that blower, so which is good, especially considering we're sucking off the header there. So now we're not really caring about the air temp. We just want to see if the tubing makes any difference. And then after we're done with the tubing, then we're going to go to testing horsepower, parasitic drive loss on the blower. Very cool. Oh, it did pick up. 1612. So this is the exact same tune-up. This is exact. I mean, we literally just changed that pipe. Let's show previous. Yeah, that's pretty good. It's better all over. So let's see what it picked up. This gold line is previous with a 3-inch pipe, and this is with 4-inch pipe. And let's hide that. Let's go see what we have for boost. So obviously it would have picked up. Yeah, picks up almost a pound. Well, how about them apples?
Nice. Too bad for 20 minutes. Half hour.
Yeah, yeah. So remember that. Basic plumbing principles always apply.
Basic.
Less bends, straighter pipe, bigger stuff. Is always beneficial in mass airflow. All right, cool. Dang. So now we're gonna put that pipe on.
Yeah.
So here, we'll show you this pipe, and then we'll show you how we're putting it all on, because it's pretty interesting. So as you're processing it out right now, you start thinking to yourself, how much horsepower does it take to drive that blower? And then I'm going to show you how we're going to figure it out. So this is their tube they've made. Now what this is all about is they've already figured this all out on their test stand. So you guys got a great big electric motor that's sitting there spinning at speeds.
You got an LS running it.
Oh, you got an LS running it right now. So they got it. So they have an engine that's running it themselves, and so they're measuring boost here, measuring temperature somewhere else. Oh, right there too. Yep. And then this is actually a restrictor, because how this works, and people do not understand this, and I've talked about this a lot of times. If you run this thing wide freaking open, what it does in a turbo, all it does is overspeed and moves a bunch of air. In a centrifugal, what it does is it puts a whole bunch of load on the blower, because it then asks it to move all the air that it possibly can unrestricted. It's a big deal. It doesn't just overspeed, it just moves a lot of air, and it drives the parasitic astronomically high. I mean astronomically high. Hurts the blower case, hurts the bearings, it hurts everything in there if you do that. So when you dump a compressor side, because it's not like a turbo where you're dumping exhaust pressure off of it. It's not even remotely the same universe. You're dumping compressor side air off of this. When you do that, think of it like a shop vac. Okay, you got your shop vac and it's sitting there, and you put your hand over the shop vac. What's it do? The motor speeds up because it gets unloaded. Okay, the inverse is exactly the same. The inverse is, if it's open, it's got maximum load on the blower, maximum load on the vacuum. It's the same thing, and that's a simple process of how you think about it. So they have this set so it restricts, build a certain amount of boost in here, a certain amount of back pressure, which simulates how much flow is going through there. You're also measuring flow. There, we're not doing that. We know where this needs to be set at in order to get X amount of pressure, yeah. X amount of flow.
Yep.
Okay, so they already know because they've already tested this. So what we're actually going to do is, and this is the simple stupid part, is we're going to disconnect everything off of the engine, including this intercooler. We'll just take that tube off, and so take the whole intercooler right off of it. And then dyno the engine NA. Just how much horsepower the engine makes all by itself, and no blowers on it, no boost, no nothing. And then we put this tube on the blower, hook the blower back up, but not run any air to the engine. You'll see this. The air will just exit right out the room, go right out the room, and then any difference in the horsepower, run the exact same sweep. Any difference in the horsepower between totally NA, not driving anything, and then driving the blower but not getting any of the benefits of the boost, gives you how much horsepower it takes to drive that blower. It's very cool. So we're gonna go there, have these guys go in there and put that all on, move the intercooler and get that stuff all out of the way, and then we'll run it. If you want to see what this contraption is going to do, you need to watch it. Alright, so that's pretty consistent. Now, I have not worked on a really super good tune. We could probably make this a little bit better and a little bit smoother for an NA tune, but we're not super concerned about this. Actually is on the boost tune, so I haven't done a separate tune up for this. This is just where it's at, because when I tune stuff, or when I have Kyle tune stuff, we try to make it run everywhere. Let's put it that way. So anyways, that's good. We'll have that good as a baseline there. And let me correct this, because that was NA. All right, and this is it's actually a really good engine. We did do some other testing before, and it's right in that range. It's a nice piece, and it would probably be like 875 or something like that. And I can smooth this stuff out, but I'm not going to bother doing that because I don't want to change the tune-up. So now we have that is the base. So now we hook up the belt on that supercharger, and then figure out / already have / don't have a clue where to turn that little cone nozzle to. But we're going to set it up at a certain boost reference or boost number. Now, is there a multi-million-dollar way of doing this exact same thing? Absolutely. This is not the multi-million-dollar way, but I'm telling you, this is really actually quite accurate to do it this way. It just looks a little hokey. So let's go put the belt on that thing, and we'll run it up to. Todd's gonna stand in there. I told Todd, instead of running it through the block, because see, we have to have the tube anchored with that block because the tube is gonna go crazy. I said it would be a whole lot cooler if that's Todd in a gray shirt, if Todd was in there holding it while I was dynoing it the whole time. I thought that would be sweet. Like a fire hose of air. Would have been awesome. But he's a sissy, doesn't want to do that kind of crap. So we had to come up with a extremely heavy small block Ford block that we're using for ballast.
Just a quick little check it.
Yeah, I mean the warranty was over like last week. So it really doesn't matter if we break Scott's engine again, but. So. Maybe a little bit more, maybe like a. Perfect. Okay, this is that magic spot where we pause and make sure that we're not going to kill each other. Or kill something else here. Make sure everything's right. So,
Can you zip tie on that valve so it doesn't turn?
Huh? Why don't you run the jam nut down on it?
Oh.
So, yeah, I don't think anything's gonna fly off. Nah, it's all pretty good. That block probably weighs like 200 pounds because it's full of concrete too. So, it's a solid block. So I don't think it's going anywhere. It looked pretty good right there. So now we'll come in and we're just going to duplicate that same pull. And what I would not be surprised at is if it won't rev all the way up. I've had that before, where the dyno can't unload. If it well, I don't know. I don't know. Let's find out.
The one in the other room.
Well, there you go. And then So, I don't know if that was on, were you videoing this? Probably on camera. This is the craziness that happens. So keep in mind, when you blow a boost tube off on a centrifugal and it's just dumping in air, this is the kind of crud that's happening. So, there is our comparison, which is just insanity. We have a grand total. Let's see where we're at here. And let me get this in a better line. One that's a little easier to read. Alright. Green line is NA not spinning the blower. And blue line is spinning the blower. Oh yeah. So this is flat out. Yeah. And we'll look at the boost curve and see what it's actually making, because I think what it ends up doing is I think that it's probably still flowing more air than what it actually is on the engine. So if we didn't maintain 12 pounds or 13 pounds of boost, then we know that it didn't do it, right? Okay, so right there, that's 380 horsepower, which I think is pretty much wide open. And you can see it significantly changes right here. It gets significantly ticked off right in this area where that parasitic even multiplies even more. That's why I think it probably didn't make the boost. So this number here is 220, which sounds a little more realistic, a little more normal. So let's go back and find out where we're at for boost. Make a report. Well, shoot, I don't know. Now I have to think about it. It says it made 27 pounds of boost right there.
It made a bunch of boost on our tester. That was up to 25. We tested it. Like just steady state, you know.
So how do we simulate? So at the...
If we open the valve more, we'll just have less boost.
It would have less boost, but it'd drive more, but it should take more.
I bet it doesn't take more. We've seen on our stand that when you put more load on it, the horsepower goes up and you can't get the RPM out of the motor.
Put more load on it when you
put more load on the supercharger, by making the boost go up. It takes more horsepower to run it.
Okay.
I don't know, we've never seen 27 pounds of boost.
I ran up to 30. 30, 3,
Oh,
4 turns.
open it up.
Yeah.
Yeah.
Like if we know about, was it 8 pounds at 4,500 or 4,400? If we go to 5 pounds or something maybe, or even maybe a little less than that even?
I don't know. Yeah, I don't know. Let's...
Because then it won't spike to 27.
Yeah, now it's interesting. Oh, so what's going on there too is if you probably saw sparks flying out of it. What's going on is, especially on the front, because the back it's ticking the starter or the starter pinion. That one don't really care about, but the front it threw sparks off of the crank trigger because it is actually pulling the crankshaft that far forward, pulling it towards the crank sensor.
Oh, really?
Oh yeah.
It's lifting it up that much.
Yeah. Belt drives. That's why it's pulling the bottom pulley up towards it. Every centrifugal does it. I mean, that's just the way they are. That's why you break LS cranks. That's why you break a lot of stuff, is because they'll break the snouts off of cranks because they're pulling on the front of the crankshaft so hard. All right, so let's go ahead and open that thing up. That is actually a good reason to have twins, because then it's, let's see here. So it would be,
Still pulling it upwards though.
so this one pulls that way. No, it's a little bit Yeah, it still pulls it upwards. I mean, it still would have to pull it up a little bit, but it wouldn't be just one direction, I guess. All right. Well, that's interesting.
Actually, yeah, because the one will be pulling, because it's always the drive side, so that one's pulling out this way, that one's pulling out this way. So it is opposite.
It is opposite.
One's kind of on the top, one's on the bottom too.
Gotcha. Huh. All right. Let's run that again now with less restriction. Let's look at this. All right, so yeah, okay. So open restriction made less boost, and it made another, well, the blue line right here, the blue line is what we just did, the green line is what we did at the first boost setting, NA obviously. So that is another 22, whatever, that's another like 40 horsepower more to drive it.
So it's just like what you're saying.
Yeah. I thought I was, for a brief moment, I thought I was going to be wrong. I go, oh my gosh, maybe I've thought about this wrong all my life.
We don't have a horsepower. Oh, hey, we're not into the secondaries. That's what we're looking at.
Yeah. Yeah. So no, so the more air it moves, the more horsepower it takes.
Interesting.
Yes. So.
No, we don't. That's why we do this, right?
Yes.
So that was how much horsepower? So it'd be this peak number there, then, basically. That's what
Well,
we're looking at.
I mean, well, now it does, down here, if I would have run it out farther, maybe it ends up taking about the same. So I wonder if it just is, it probably just gets at that spot of the map, period, I would figure. Once it reaches a certain spot in the compressor map, it probably doesn't ever, once you run it off the map, you can't run it off the map more.
Yeah.
I mean, maybe it just stays out there. I don't know. So see, this is the way you figure stuff out. We just test it and trying to think about it here.
This thing doesn't. We can stall that compressor by, cranking up the boost where we can actually see that because the flow will stop. So we look at how much the flow is coming in, in our test tube, and as we crank up the boost, when the flow stops, that's when we go to another part in our map. So go to a certain RPM, we run it up, we set it at a boost level, look at everything, the flow, look at CFM, look at temperature, where that is in boost. They go up 5 pounds of boost, look at the same thing, CFM.
Right.
So that's how you make a compressor map. So
Okay. So here,
but we don't know horsepower on our stand.
Right? No
Right.
horsepower numbers.
and that was it. That's it. 12 pounds of boost.
Yeah, that's pretty much right there.
So I would. It's that awkward thinking moment.
We're watching the process happen right now.
Insert the Jeopardy theme song in here.
This is where it's doing a little circle of death on your computer.
Still thinking.
Still thinking.
Still thinking.
Huh. We will, we're going to continue processing that out. But this is how the whole system works. So, and I've done this before where the last time I did this, which was quite a few years ago, so I did it with a bigger blower, not a TorqStorm, but a bigger blower than this, and just to see what it would do. And when I went to just unrestricted, wide open tube, I had it on a 540 NA deal. It made 750 horsepower, and I couldn't get the motor to rev over 4,500. It just went. It just was dead. I mean, it was. You couldn't really do it that way. So I always figured that at best case scenario, that thing would probably take somewhere in the neighborhood of 500 horsepower right there, and we're less on this, but it's interesting information, isn't it?
Mm-hmm.
It is.
Still does the same thing where, just starts pulling the crankshaft, pulling the snout far enough that it starts touching the crank sensor. So a lot of horsepower to drive that kind of any kind of centrifugal, and I'm not 100%. I don't think the boost number is a direct, can't be a direct relation to when it's flowing through the engine. The only way we would know that is we should put a flow meter on the inlet of the supercharger to see how much air is it really moving now
On the engine.
when we're doing it this way,
Oh.
and on the engine.
We know what it is on like this here, because we can do that. We can do that test. We can't do running on an engine and do that at the same time.
Right. Yeah, well, but what's your LS make? If your LS only makes like 400 or 500 horsepower,
They don't even make that.
then it couldn't even run it.
Right. It runs it. We've got numbers up to a certain point. I want to say 60,000
Oh yeah.
impeller speed, and then our engine won't turn it. It just we're wide open and won't do it.
Right.
Yeah. So we've got numbers for airflow up until a certain point at boost, at 5 pounds, at 10 pounds, and we've got a CFM number for that. It just depends if it's not as high as this thing's revving it for sure, but we've actually got the CFM and then the boost number.
Yeah. So where's this magic? So at the 6,300, where are we spinning impeller speed at?
I have to figure it out. It's probably around 50 actually. It's less than that. It's probably 45,000.
Okay.
Because at 67 it was 59, so it's probably right around 50.
All right.
Our test engine, we have a 16-inch pulley for the blower.
Right.
So we don't have to spin as hard.
Yeah,
All right.
It just runs out of horsepower, so
Yeah.
we'll not turn it anymore.
Yeah, will not turn anymore.
Yeah.
Yeah. So very interesting information. Like I said, I'm gonna think about it, and if you got any comments, you can actually comment on this, on what is going on here, because I don't think it is not a. We ran the engine at 13 pounds of boost, and it doesn't pull the crankshaft over hard enough to touch the crank sensor. But here at 12 pounds of boost, it's pulling on it, loading it so hard, it pulls the crankshaft over and touches the sensor. So there's not a direct correlation, not absolutely direct, to the way the engine eats air and makes boost. So there you go. There's your homework assignment for the night. So I think we're gonna check out because this is getting to be a long video. So thanks to the TorqStorm guys. Only kind of information and hillbilly engineering on this block and tube setup that you're gonna find at Steve Morris Engines. I'm Steve Morris. Have a great day. All right, never mind. In conclusion, we just had to come back to this. So we've been sitting here talking about it. Then the engine's running. The engine, so just for the sake of round numbers, this is not exact numbers, okay, so don't get hung up on it. Let's pretend the engine is drawing 1,000 CFM of air. Here, we are only asking the blower to move, which has always been my point. When you create an open orifice, it drives this parasitic up so astronomically. We're seeing that. When you, if you're basically blowing the blower into a vacuum, because the engine is creating a vacuum, it's drawing CFM. There must be the magic spot of why it is different on the when it's actually running through the engine versus running outbound. So there you go. Yeah, okay, now we're done. Have a great day.